Okay, this is more topics on rational functions, section 2.5 here. It says the function n of t equals 3t plus 1 times 2t minus 1 squared over 4t minus 5 describes the number of deer, n, found in West Virginia if hunting was actually illegal, where t is the number of years after 1920. According to this model, what is the population of deer approaching as time approaches infinity? Well, what we'd like to know on this problem then is the horizontal asymptote, because as time approaches infinity, the x-axis, we would like to know if the population is going up or is it leveling off. If it's going up or going down or whatever and continues to go down or continues to go up, then it does not have a horizontal asymptote. If it levels off, then it would have a horizontal asymptote, and we'd need to know what it levels off to, the location of that horizontal asymptote. Now, the easiest way to do this is without Excel. If I look at the power of the numerator, it's to the third power, because this 2t would be squared, so that gives me 4t squared, and then times this 3t gives me up to 12t cubed. So this is up to the third power the variable is. On the bottom, it's up to the second power. And we know from section 2.4, the very first page on section 2.4, that if the power of the numerator is greater than the power of the denominator, the function does not have a horizontal asymptote. So therefore, this function does not level off. The population of deer would be growing without bound. Now, we could FOIL this thing out, which I just did here, foiling the 2t minus 1 times the 2t minus 1, then take it times the 3t plus 1. And you could always use the poly sheet to help you FOIL these things together and get something like this. Now, I went to the Excel sheet and typed in my coefficients for that simplified expression. And what I did is I wanted to find out if this thing does not have a horizontal asymptote, and it says right here it does not have a horizontal asymptote. That means that this graph, I clicked to find the vertical asymptotes in that, and I set the graph to go from negative 10 to 10, and it might look like it's leveling off. Here's the vertical asymptote right here at 0.5, but it's not. If I go, let's say, out to 100 or so, then you can see this graph just keeps on going up like this. Now, if the power of the numerator is 1 greater than the power of the denominator, which is the case we have going on here, this is to the third power and this is to the second power, or you can even tell back here, second and first power makes third power over second power. So if the power of the numerator is greater than the power of the denominator, you do not have a horizontal asymptote. If it's 1 greater, if the power of the numerator is 1 greater than the power of the denominator, like this case, then you have what's called an oblique asymptote. Now, oblique asymptotes, you would need Excel to find those, and so I already have those coefficients in Excel here, and at the bottom, it tells you what the equation of the oblique asymptote is right here. So it would be y equals 3/4 x plus 11/8. And you could always switch these over to decimal format if you wanted to by, let's see, format the cell and maybe switch it to a decimal if you like. And we could get the answer as a decimal and even more decimal points if you like. But that gives you the equation of the line that this graph is getting closer to and closer to. So basically, this graph here is very similar to the graph of this line, y equals 0.75x plus 1.38, except it has this little blip in it, and it just gets closer and closer to that line as it goes on. So let's go on to the next problem. On this problem, it says for this function where the numerator is to the 4th power and the denominator is to the 5th power, what is the function approaching as x approaches infinity? Well, this is asking what's going on in the long run and when x gets large. Well, that's a horizontal asymptote question. Now, on this particular problem, the power of the denominator is greater than the power of the numerator, so this function has a horizontal asymptote on the x-axis. In other words, it has a horizontal asymptote at y equals 0. So the function is approaching 0, okay, because it has a horizontal asymptote at 0. Now, we could not do this problem on Excel because the power is too large. On this particular problem, same thing. It's asking about the horizontal asymptote. What is x, as x approaches infinity, what is this function approaching? The height. Okay, well, the powers are the same, so we need to look at the leading coefficient. Now, we really don't have to take this thing and raise it to the 4th power. All we really need to do is take that 2 and raise it to the 4th. Well, 2 to the 4th is 16, 3 to the 4th is 81, so that's what it's going to level off to, 16 over 81, because when the powers are the same, you look at the leading coefficients, and that tells you the location of the horizontal asymptote. Now for this function, it says, this is back to the earlier one, what are the x-intercepts of vertical asymptotes? Well, you get x-intercepts by setting the numerator equal to 0. If you set the numerator equals 0, set each part equal to 0, we would get t equals negative 1/3 from here, and we get t equals 1/2 from this area. The vertical asymptotes by setting the denominator equals 0, and if we set the denominator equal to 0, we would get 5/4, and that's worked out for you. And here, just taking terms to the other side and dividing by the coefficient to get those things. Let's see, on this one, it says what are the x-intercepts of vertical asymptotes? Okay, the x-intercept is where 2x minus 3 equals 0. So setting that equal to 0, we would get 3/2. That's the x-intercept. And the vertical asymptotes, setting the denominator equals 0, so we get 5/3. And we'll move on to the next problem on the next video.